Hello. In this lecture, I try to clarify the regression analysis and what is regression analysis. Actually, it is very important in the statistics and as well as in some research work in social sciences. So you should have a clear idea over this concept, the regression analysis. So here, one thing should be mentioned that the term regression was coined by the Sir Francis Galton uh, during 1822, 1911, and from England, and who was studying the relationship between the height of the children and the height of parents. Okay, so height of children's height of children and the height of parents is a matter of his research. So, what is regression analysis? Look, regression analysis is concerned with describing and evaluating the relationship between a given variable. If you look in my example, then it is the given variable, which is also called the independent variable. Okay, and one or more other variables that is also called the explanatory variable or independent variable. This type of relationship is considered in regression equation or regression analysis. So in my example, in this slide, you can find it. This is a simple regression equation. This is a simple regression equation because yt is the dependent variable at time t. Here time period is t, and alpha is the intercept term, and beta is the slope coefficient. It is a parameter, and x1t, it is an independent variable. Here time period is t. Okay, one independent variable and one dependent variable. So this is a simple regression equation. Now, if there is a number of independent variables, if there is more than one independent variables, then we call it a multiple regression equation. This is a multiple regression equation where one dependent variable, that is yt, and another, and one independent variable x1t and another independent variable x2t. Okay, so in practical, you can have an example of simple regression. Suppose y is a sales and x is the advertising expenditure. X is the advertising expenditure. If the expenditure, whether there is any relationship between the two variables, this is considered in regression equation. One is one is one is sales and another is the advertising expenditure. If there is an increase in advertising expenditure, what happens on the variable sales? Okay, so this type of relationship is considered in simple regression equation. In multiple regression equation, you can find y is a with an example. Y is a y is a y is a variable that is the consumption expenditure of a family. Consumption expenditure of a family, and here suppose x1 is the family income. This is the income of a family, and it is the financial assets of a family. A family always has a financial asset. So financial assets do have some effect on the dependent variable consumption expenditure. So this is a multiple regression equation. Okay. This is a practical example of multiple regression equation. So next, look, now what is the objective? What is the objective of studying regression analysis, or studying the regression equation? What is the focus, the value y for a given set of x? Okay, given set of x, focused the value of y. Forecasting is important. Forecasting is important. Okay, the regression in the why do mm, uh, we study the regression analysis? For the forecasting purpose. Forecasting of what? Forecasting of the dependent variable. What is the dependent variable? In our example, y is the dependent variable. Okay. So this is one of the objective of the regression analysis. Examine if any of the x's have a significant effect on y. Okay. This is another objective of the regression analysis, whether the values of x's have a significant effect on the dependent variable y, whether it has a significant effect. Look, this is a independent variable which is called the income of a family, and this is another independent variable, the assets of a family. Whether x has a significant effect on y, and whether x2t, that is the assets of a family, do have a significant effect on in dependent variable of expenditure, consumption expenditure, it is a matter of concern in regression equation. Okay, so these are the objectives of regression analysis. Now, mathematical relationship and the statistical relationship. So, what is the mathematical relationship? Suppose y equal to 5 plus 2x. Y equal to 5 plus 2x. Look, y, suppose y equal to 5 plus 2x. This is 2. Okay, y equal to 5 plus 2x. So if I put a value 1 in case of x, then we get 5 plus 2 equal to 7. That is the value of y. This is the exact or unique value. Unique value. Okay, you can get the unique value in mathematical relationship. You can get the unique value of mathematical relationship, but in statistical relationship you cannot have a unique value. A statistical relationship does not give you the unique values of y for given values of x, but can be described exactly in probabilistic terms. Okay, so look at here. In my statistical relationship, y is equal to alpha plus beta x plus a. This u term is included in a statistical relationship. This is the disturbance term. This is the error term. This is the disturbance term, or this is the error term. So, so this error term is included in statistical disturbance. Okay. So next, Now look, what is the stochastic relationship? What is the stochastic relationship? This equation shows the stochastic relationship. The statistical relationship is the stochastic relationship. Mathematical relationship is not a stochastic relationship. Yt is a dependent variable and xt is independent variable. Suppose yt is is consumption expenditure and xt is the income of a family. Then alpha plus beta xt is the deterministic component. Is the deterministic component because if we do not consider the ut, that is the stochastic component or the error term, we have a unique value for a unique value of y, that is the consumption expenditure, for given value of x, that is the income of a family. So this part alpha plus beta xt is the deterministic component. Okay, and now the stochastic component. What is the stochastic component here? This is the disturbance term and it has a probability distribution, or you can say it is a random variable. It has a probability distribution. It has probability distribution, and so this is the stochastic relationship. Why should we add an error term u in this relationship? Why? What does it mean? What does what is the role of ut in this relationship? Un, unpredictable element of randomness in human responses. This term ut represents the unpredictable element of randomness in human responses. Understand? Human responses is unpredictable. It is considered in this relationship by ut. If I do not introduce ut in this relationship, then we do not consider the unpredictable element of randomness in human responses. So this unpredictable element of randomness in human responses is considered here by ut. Effect of large number of omitted variables. For that reason, we have introduced ut. We should consider the effect of large number of omitted variables, because in case of our example, that is the expenditure of a family depends on the size of depends on the income of a family, but also it depends on the assets of the family. Also it depends on the size of the family. So these variables have not been considered in this equation. If we consider only this part, okay, yt equal to alpha plus beta xt is considered only, then this omitted variable, that is the assets of a family and size of the family, are not considered. So the effects of the large number of, there are other many omitted variables are there, so these variables are considered through this ut. Okay, so this is the importance of the stochastic component, that is the error term. Another reason is that there are some measurement error in y. So measurement error in y is considered to ut. So this is the importance of introducing stochastic component or error term in this relationship, the stochastic relationship. So I hope you try to understand what I try to explain about the regression equation, and what is the what is the key element you should consider in case of regression analysis. In my next lecture, you can understand in better way. So hope you enjoyed this lecture, and thank you for enjoying this.